Good afternoon, everyone. Dustin Martin here on behalf of ThermoElectric Solutions, a new startup venture that's looking to market a new product to the utility generation industry. We'll talk a little bit about it, but first of all, I want to thank you all for just taking the time to listen to this, and hopefully you'll get some enjoyment and maybe even think about contributing. So let's talk about the problem and some facts that we have in the industry that may be a little surprising. Out of the 4.1 trillion kilowatt hours generated in 2016, about 2.6 of those were fossil fuel powered plants. That's around 3,200 fossil fuel active plants out there, and about 1,800 of those are natural gas, which is currently the preferred source in the U.S. due to the lower emissions as compared to coal and oil power plants. And those plants are being built continually. There are about another 36 gigawatts in plans over the next 2 years for construction or in the planning phase. And those are the source of plants that are being built to replace the coal plants that are being decommissioned due to emissions reasons. So recognizing that this industry is growing, but the plants themselves, the efficiencies have improved, but the range is still only between 35 and 55% efficient, and that's based on the energy in from the coal or natural gas or oil or whatever, and what we're actually getting out of that. So that's about 3 trillion kilowatt hours wasted in 2016 as waste heat. So our solution to that, and recognizing the efficiency challenges of these plants and even the environmental impacts of them running, is a thermoelectric generator, which is basically a newer technology that's been out there. It's been used in some other industries, such as microprocessors and things like that, but it converts waste heat into electrical energy. And some of those in the smaller settings with higher temperature differentials can range up to 12–13% efficiency. We're targeting an efficiency based on our parameters of around 7–10%, which is still substantial. But those heat sources that we have from these plants are the stack gases, the condenser heat that are basically emitted to the atmosphere or the environment through a cooling tower or a river or lake, and then maybe even some motor heat sinks or things like that on the smaller scale that we'd be looking at, branching into. And the benefits of that is recapturing, a portion of that waste heat that's typically just being sent to the atmosphere. And the advantage that we have over that is that they do continually run. So if we look at our product, if you look at the graphic, you've got a capacity factor, which is basically how often your product's running as compared to how long it could run, based on 24 hours a day. If you look at the install cost as compared to wind and solar, we're still cheaper to install based on some research that's been done than a solar power plant. But it's not quite as cheap as a wind power plant. But then if you factor in the capacity and how often wind and solar run as compared to a continual operation of a thermoelectric generator, we're actually cheaper, pretty substantially. The biggest factors that we need are steady state temperatures and high heat flow rates. And our materials, we're going to have to tailor those, whether that be bismuth telluride or lead telluride. We're going to have to optimize those to ensure that for our market we're doing the right things. But that's all going to be part of our development stages up front. But once we have a product development, we can tweak that, and it is flexible so that anything that emits waste heat, we could recapture some of that potentially. So if you look at our competition out there, specifically in this industry or external to that, there are companies doing this on a smaller scale, and they're targeting different industries or different markets, but no one is actually targeting the utility market as a potential to recapture some of that. The biggest competition that we see is going to be substitutes such as solar and wind that do have a pretty predominant hold on the industry. And we don't believe that companies are going to quit investing in those, but the goal is to ensure that these companies to market it to the point that they're willing to take a risk and maybe add it to their portfolio of investments. And if we can do that initially and get that marketing jump and kind of even the development jump on some of these other potential new entrants that are still making smaller components like this, we feel like we'll have a substantial advantage from a competition perspective. So if you look at the current market that's out there, 2016 U.S. utility industry invested around $91 billion. That's a lot of money to be invested, but to add on to that, 36 plus gigawatts of natural gas plants are being added continually over the next 2 years. So there is a lot of investments in fossil fuels and fossil fuel power plants because they recognize that the challenges from stability purposes of solar and wind is they're not always available. You need that base load to ensure that the grid's stable. So we're targeting that, as these companies are going to have to continue to handle that until we get the grid to the point to where it can handle these renewables, which is still probably 15 to 20 years down the line or more. So really that's why we're going after these fossil fuels, is we recognize the efficiency challenges of them, and we think it's a good market for us. The last piece of that is that we want to target the big companies that are investing that money, which NextEra, Southern Company, Duke Energy, companies out there that are investing $5+ billion a year, sometimes upwards of $12 billion. So that's a lot of money being spent, and those are the companies that we want to target. And we'll talk about how we choose those and where they actually are geographically. But the key here is to exploit the environmental benefits from ours as well as the efficiency improvements of our component. And if we can show both, you're making the company money that you sell your components to just based on the efficiency improvements, but they're also getting bonus points for investors and stockholders in the environmental gains that they're getting out of our product. So we see that our edge, if you look at the substitutes that are out there, whether that be solar, wind, or even potential component replacements such as a low pressure turbine steam path replacement, our target install costs are substantially below them. And what that translates to is a lower cost per kilowatt hour install, and we have pretty much no maintenance. You may have a cleaning annually to ensure that there's reduced scum on the components, but they're pretty minimal components themselves, and it's just basically in the materials that's doing the energy conversion. So that lower install cost means more capital for these companies to invest in other areas. Another piece of that is the higher capacity factor is the fact that we're running more than solar and wind means that we're going to have a higher return on investment than those companies as well. Not to mention the efficiency gains and even the environmental impacts. As 1% efficiency on a 33% efficient plant, you're talking about a 3 times environmental gain there from carbon emissions. So that's the different things that we're seeing as our component has an edge over these other people, and we really see that as very marketable going forward. So the challenge that we see for our company is going to be the customer acquisition, which this industry is very tight-knit. They're not in direct competition with each other usually, specifically in the regulated sectors. And energy rates are regulated in the regulated sector by the government. And even to build onto that, the government gives these companies the ability to recollect up to 10% or more of the capital invested per year back from tax or ratepayers. So if they're making an investment with us and then they're getting some money back based on the rates invested there, plus you're getting the fast return on investments, we see that as a distinct advantage over our competition. But to acquire those, we're talking about visiting trade shows, corporate pitches, different things. We got to get the industry talking, and we recognize that because once they begin talking, they're going to help each other out, as we always have seen that they have. I've worked in the industry, and I've seen that that's the case. They're going to help each other out to the point to where, if a company's seeing a benefit from it, then another company is going to be willing to jump into it and do it. And these companies use that operating experience pretty heavily. So if we can get them talking, that's going to be a big benefit for us. But the real target is basically the Midwest and the Southeast, because those are both regulated energy markets, and they're also very fossil fuel powered heavy markets. So those are going to be our 2 geographical locations that we target initially. So if we look at our business model, which basically means a $1,000 kilowatt install, the average flue gas stack has the potential for up to 6,000 kilowatts there. But we see that the typical customer is probably not going to spend that kind of money up front. They're probably going to maybe spend more like $1 million, which means that they're going to have about a 1 megawatt order if we can hit our target price. But for the target install cost for us, from a cost of goods sold, we're talking about $500 per kilowatt, which means that we're looking at about a 50% net gain there. So that's pretty good if you look at across the board what our potential is there. But for a customer that does have a 1 megawatt order, total project cost would be around $1 million for them. If they only run 50% of the time that plant, you're talking about a 6-year gain on return on investment. If they do run 100% of the time, it could be as little as 3 years. So, an investment that has that high of a return on investment in this market is pretty much unheard of. So we feel like that's very attractive for us. So given that, if you look at the forecast that we have out there, we think that we're going to have about a 2-year development up front. And it's going to take some time to get the components to the point to where we feel like they're ready for the market and get them robust enough for continual operation of 15 plus years with minimal maintenance. But once we get that and we spend that time investing in marketing and socializing that throughout the industry, we feel like we could have a first sale, maybe a small order in 2020 of around 500 kilowatts. But if we can get that and we can get that operating experience out there, maybe that will double by 2021. But then by 2021, you should have enough validation in the market that we feel like we can establish our product and it'll rapidly grow from there. Based on the ATAR model we show, basically 80% of the industry recognizes our product, and just 1% is willing to take a risk and try it. We would have over 2,800 kilowatts of orders by year 5, and that immediately turns our, based on our financial forecasts, our product profitable. So just given that, it presents a pretty good investment from our perspective, and that's why we were really pushing it, and we hope that you see the same in it. If you do have any questions, feel free to contact me, and we can talk about it a little bit more. But again, I just appreciate your time. Thank you.